Welcome everyone to more live Linux kernel development here, continuation of live DDR5 SPD hub NV non-volatile eeprom data reading here. Let's see if we can make this video as successful as another previous live kernel development video here on our channel. So the summary, previous video, right? What is it for? Why do we do that? Previous video, let's add here. So I have here already basically the tested code. For what we would need for eeprom reading, we only need to wire this up. So let's inspire here from, here's some bus log. Let's inspire this here from the DDR4 eeprom driver. Where do they have this? We have device called new dummy device. Okay, this is something else that is, I believe, for some shared stupid DDR4 thing. So the only thing we need is here this binary attribute stuff. Where is bin attribute group? So basically we need something like that here for this read stuff. I only slightly wonder how that works. So the Linux kernel is at times really strange. I mean, it's funny that they fight C++ so hard and object orientation when they have k-object and basically do C with classes. And it's like, yeah, basically in 80s C with classes like, but object orientation is bad. They also have quite some magic, macro and whatnot stuff for lots of stuff. So basically, what is this? So we need something of, okay, we can kind of copy such defines here. And we can use similar defines, of course, rename that our stuff. So it's just set page. Okay, we have that already in some other register, M11, whatever. And so num pages would be, so we have page size of 128 bytes. What do they do with the shift? We have probably, let's see, we have 124 divided by, so it's 8 pages, so num pages 8, and what do they probably shift 7. We will see how that actually works out, and then of course rename that here to SPD stuff. Yeah, you could use some substitute, but whatever. So I would, in general, code this differently. We just adapt to the 90s style of C code of the Linux kernel. But yeah, you know, the modern stuff of C++ and Rust and Zig and so on. So what else do we need? This I2C stuff we have already. We need some page thing. We probably theoretically also need some locking, also theoretically, when we read, because we have now two features. I wonder if that will work. I hope it, because the magic of Linux kernel, because we will have here, we have here two reads. So I wonder if that even will work in one driver easily. Maybe it will not. How does this read stuff? Because so basically we will have, although maybe it, yeah, actually I would hope it works, because we will have, I would hope that would work, as hwmon sysfs exposed sysfs attribute things, objects, and some more main eeprom things. So I would hope that would work. So yeah, let's maybe copy that in Whool and modify this as needed. So they don't have here any other devices. So let's copy all this stuff. And so get current page we probably don't need, because the other DDR4 stuff was more glitchy. And so it's H, so that is all HW, register map stuff. So detect, let's put it here. And then that would be, do I still have this? Oh no, I didn't have this copied. That would be some SPD 5518. And then some more substitution. Learn from the best, also slightly rename that to lowercase SPD. Okay, we need a current page. Do we have... okay, we need to do that in a second. So basically, we don't need to check. I would directly fail because we're not DDR4. And current page. Also we will, so this is global, I believe, in this old, because the old thing had a shared, like all the DDR4 SPD things were on a shared, one or two shared, like additional devices, secondary device addresses. And so yeah, they have that here static, so we will have that driver private. So we need to modify that a little bit. We can, I mean, we could for a quick hack, you know what, let's for a quick hack make that here static int just for testing. And then, so we will obviously need to replace that. The selection is slightly different, mostly another register, which I'm not sure. Yes, that is vastly different. So just naming. I mean, a lot. If you are working in others, or like in general, normally for big stuff I would use Emacs and would use some more wider substitution. So what we need to do is, because we need, so we have a 128 byte page. The other was 512. So page means like one chunk block of memory. In this case, on I2C bus, could also be in other stuff like think hard drive, IDE, SCSI sector and stuff. So we need to compute in which page that is. So that is shift that by 7. So yeah, that SPD that probably should work like that. Shift by 7. We changed that in for EE 1004. That was 8 for DDR4. So we have a page and offset. So that is basically shifting that to the right. Basically cheap division by power of 2. Then mask this here by the page shift for the offset within the page, and then set the current page, and can't cross boundaries. So if that is, if the offset plus count is larger, then limits this one read. And that is why the other driver where we inspired from Blockworks, or whatever. Does it work like that? Offset count. This has a chance to work, I believe. We have client offset. Yeah, that probably should work like that. So this is the callee. So for each file operation of eeprom read, so like Linus Torvalds C++ object orientation stuff is bad and stuff like K object, but no further questions. So read data. So this is slightly different. We don't have this concurrent access from other EE10 1004, 1004 stuff. So, I mean, theoretically, we would need to log that, but we'll do that later. So we don't have concurrent SPDs, but we have the concurrent temperature reading. Although I believe it actually could work. Let's see if it works without logging, because that is why the DDR5 page size is smaller. I believe you always, at least in this mode, unless you choose another mode, but in this basic I2C and not I3C access mode that we select on device initialization and probe time, you should always have this non-NVM, so non-volatile registers, basically the internal register things. You should always have them. All right, by the way, offset, that is also, we actually need, here offset, now that I think about this, we need actually that here plus offset. Theoretically, we probably should make that a define. If we don't have a define already, maybe we have, maybe I don't. No, I have this hard-coded there. Yeah, we could make this some. I think this is mem. I think they call this like memref or so. We will check later. So we have actually we can. Here. Nothing like pressing undo in the right moment. So that is also why the page size is only half of DDR4, but it doesn't, at least in this old-fashioned compatibility thing. So we also renamed this here. So the only thing I didn't instantly see in this skeleton where we inspired from is how this is wired up here for this eeprom stuff, the SPD. Need to check that in a second. So with this mutex we don't have yet, and I guess this bin attribute stuff does that. I would hope. We also have here eeprom. Yeah, we also need to do here that. And call that SPD bin attributes eeprom. Did we call that the same? Bin attributes. Maybe that, probably that takes care of that. It's static, so that's not visible, that's not an exported symbol. It can be the same name of other Linux kernel eeprom modules there. And then, but yeah, I guess it works. I guess it should be possible with this additional binary attribute thing here. And this HW1, I guess that should work in one driver, because previously, as I mentioned in the previous introduction video live on this channel here, previous video there, live section there. Previously this have been two I2C devices, and now it's an integrated SPD DDR5 hub with integrated sensor. So attribute groups, why is this so strangely named? Let's see if that, so there's some macro preprocessor magic involved here, which I don't find this particularly. Yeah, you need to be daily Linux kernel developer to grok all this macro stuff. Okay, for set page, so that would be set page, and data is ignored. No, it isn't. Or wait a second, is it a set page? Right page? No, this looks almost strange. Because so this is entirely different. Let's fix this in a second. So yeah, then this comment is wrong, misleading and incorrect. So this stuff is what this function, this helper function does, is it checks if multiple small reads access the same page to only do this additional time wasting overhead of switching pages to the only if the page is another one. Do we have more? Here's more SPD. Do I still have the same? I have. Lucky. Oops. I messed something. Okay, so set page. So let's copy the set page stuff. So let's maybe use the same, or do we? Let's copy it first. So page is this one here, this MR11. Again, Google the top secret documents. I can't show you that for copyright reasons. And set, I love a wood, but if the JEDEC consortium wants to contact me regarding YouTube, like fair use, YouTube educational and open source development, showing that for the fractions of a second, like you on this channel, feel free to contact me for that fun. So page, so previously this was some other auxiliary I2C address nonsense. Now we have page directly here. I believe that is how it was supposed to. Right, and let's do here something like that to initialize that. So later, so this later, of course, it can't be shared. So currently we share this for all instances of this driver. Later we need here a basically, can I already? Where is my def? Here actually, do we have valid, by the way? Valid we don't use currently apparently. So then let's int current page and do here data. Where do we have? So this data and then driver data is this C with classes, object-oriented programming for poor C programmers here on the Linux kernel. This is where this is coming from. And so then let's do here, let's remove that. So current page, and welcome everyone. Current page, so that is that one. Let's driver, let's do that here. And oops, let's do here proper tabs. Oops. And then let's have here data of private data current page, and then private data current page. What is the comment there? Welcome everyone. This is clipped here in my view right now, not very helpful. In the previous live stream, saw T2 Discord server, need to join Patreon. Yeah, I should be more clever, and indeed, it would be amazing. Probably from now on, I should actually make that Patreon. That would actually, where actually was that somewhere? Can always forget where server. Probably it is. Where is bloody share? Yeah, probably or here or there. Create share, invite here, invite, and then the recurring. Stuff of joining here in this well-hidden corner of Discord. So eeprom read. What else do we need? We set this. All right. We need to set this driver data. So where do we have like rec map equals here, and then let's. Where do we assign the data? We probably malloced that here, data, and then data equal that. Do we say hopefully? So data current page equals basically minus, actually, no, let's do that -1. That makes sense. And then let's not open code that here, but let's do set page and reuse that. Set page. Oh, come on. Where's this page thing? Set current. Set current page. We need this data set though. We probably should red equal that and handle the error. Do we have a def here? We have this def. We should set this data instantly. So set this better to 0, or not better, it will not work. On my gigabyte hours board, it will not work. In default, it's probably in some i3C addressing mode, like all 1024. Where do we set? We somewhere need to set this data. I guess here, actually we have here some update log data. Okay, we probably, so this is not super ideal. We need to set this data earlier because obviously when we call there to set current page, we need that already. We don't deallocate here anyway. Maybe this would have been kind of a losing memory here on memory allocation, like good old-fashioned unsafe C memory handling. So alloc that and then set it already. I believe that should work like that. Client, it should probably, hopefully. How do we do that? Client. So yeah, def is client. I would hope it works like that. Client data. Do we have other set data here? Def map, init, data rec map. We did this earlier. We just moved it, didn't we? Register. Let's hope for the best. So client, write data there for 131. So that would be. Do we set this client already somewhere? We have here. This is the client already. So why does this not work? We have here def set current page. Def or client? Probably the I2C. No, we have device. What does it do? Then the original code probably accessed the. No, it didn't. They have the. No, this is get current page. We copied that from there, so that is incomplete. We need a I2C client here. That is I2C client def. I mean, we could probably current page. We need our def data and do we even use this update log here? But maybe we don't even use that. Okay, there we do some from. Okay, fine, we have some. Okay, because we have this already, we can also just leave this mutex in there. The original code was more complex. I mean, later we could potentially need that if you concurrently update, like if we implement min, max and stuff. So here we have the SPD data. We somehow need to access a current page. So we have here device def get driver data. Oh wait, what do we have here? I2C. Does that? This does not have the. We probably need to change that to I2C client. Did we set the private data to the, where is set current page? We set this, we have client dev. What did we need? We need this client data, so what did we call this with? Okay, so as this client, so let's call it with this client, so that would be I2C client, and set current page. Change this calling convention to our liking. And then we would have this dev, client dev, and data from get driver data from that one. Amazing object-oriented programming with C structs. And we have here client, we have then here that client, and let's see if that builds now. So yeah, attribute group stuff, so that is amazing. C sucks and complex and stuff, but we do everything with C macro and preprocessor magic. What could possibly go wrong? Name groups. So I'm obviously, should we have here bin attribute? Should we, what do we have here? So we normally bin attributes. What did we bug here? Bin attribute ro eeprom that size bin attribute attributes. So this can apparently be multiple bin attribute eeprom. What is his problem there? They have here IEEE. How does it work? I hate actually the C C Linux kernel monolithic single address space C coders, like, go away with your C++, and it's like more high level programmers like, oh wow, thank you for this general super chat donations there. Question there, Umax, how do you be able to comprehend the code so quickly? Well, I do this for 25 years, right? You should not forget this. I'm not doing Linux kernel daily. I only do Linux kernel. So like if I would do Linux kernel daily, I would know this preprocessor macro trickery. So, but I mean, I do this every month or so for 25 years. Also with my company, right? Don't delay. Can also try our company services and stuff today. And so yeah, 25 years from Linux, although I was 10-year-old teen then. I mean, when I first got in touch with Linux, it was Linux 1 point whatever, but I think I seriously started it probably using Linux 2.0 something. So yeah, of course Linus Torvalds and all they know the Linux kernel 1,000 if not 10,000 times more memorized in their brain. I only have a relatively high level monthly fixing something or implementing something. But if you once debug through something, then you learn enough of what preprocessor macros and trickeries. So what happens here is they somehow use this what's supplied there in basically this is SFS SPD groups defined, but not here's also something defined. So probably bin attributes. So this is the problem is probably with this bin attribute, so that must be something of that sort here. So what did we do there? Bin attribute. Why does this not work for us? So I guess this naming needs to be consistent. So the macro just uses this name here. There's a preprocessor macro. Usually, most people use. I mean, you don't need to all caps them, but that is a decade-old Unix C convention. And I agree. I mean, if you start to have preprocessor macros like lowercase, then I mean, yeah, that's of course pitfalls of C, because then you don't know. You type some normal-looking function and stuff, and if you have macros that are lowercase, that's pure evil. I mean, not that probably lots of code had them and stuff, but so yeah, what's going on here? Bin attribute groups. So we expect this. Why does this not match attributes? Bin attributes. It is in this order here. Why does this not? What is the exact error? We could actually run this through the preprocessor and see what is actually, what was it? Is it like, oh no, wait, oops. This was probably wrong. Oh darn, now we have, shit, no, we know we made some mistake. No, we probably have this, but yeah, must like some fails live on it. Was it, oh no, VQ, maybe I didn't even do something wrong, it just built actually. Oh, wait a second, does it build? Oh no. Oh no, wait, it was a warning. So yeah, it is a warning, but it probably will crash. I don't want to crash my workstation live on YouTube. Do we get, where is the, somehow this is not the most verbose, maybe we need the equals 1. Yeah, there is something more useful. It's only a little bit too long, maybe, all I wanted was, here, KCC. So yeah, that sucks a little bit, because this will not, yeah, this doesn't, yeah, having this in tmux scrolled prevents it. Why does this work and my modified thing not? What would here be? I mean, we could bin attributes SPD. So yeah, this is this kind of stuff. When you don't use it daily, I always lose the most time on this preprocessor magic. That was bin attributes here in 154. Bin attribute, what is it doing? Const. So that is just creating a struct attribute group with name. So name that named group. Looks trivial enough. So that should do SPD. Group. What does bin attribute RO do? Bin attribute that creates a attribute name stringify mode name read. Okay, that is the name. So expect somehow looks a little bit. So this should be eeprom. So this should create eeprom read. So we have eeprom read there. what was it? Bin attribute name size. So struct bin attribute name. So it should create a bin attribute name eeprom. So this should match this one here. Static struct bin attribute SPD 5118 attributes. Bin attribute, we should got that here. Why does this not work? What did it say? So there is some data. Do we need that? This was for my test loop. SPD 5. Oops. I mean, it also complains that this group wasn't used. Let me check this. We probably also missed some. Here is dev groups. We probably need that. Driver name. Thankfully, we didn't use that yet. Name probe new. So here's a PM. Okay, so actually, we don't have PM ops yet. So I guess we can delete that. I didn't delete that yet because I wasn't sure if we needed those. If we compile with config power management, we don't have any power management stuff to do, so can delete the suspend resume stuff here, which I don't need right now. Famous last words. Do we cause more build warnings? And undeclared. Oh, of course I copied it wrong. So, so one disappeared apparently. Unused, so that probably we should probably better check 110. What do we have here? Data that is visible. Is visible. Looks like probably we don't need it there. The other was here. Whatever. So yeah. This is not tested, not like the other stuff from last night. So it is possible that we will, because I'm live streaming from the same workstation, I'm editing that is of course. Yeah. Ambam asked you the reference tools like globals and CTEX, not for the Linux kernel, that is just too large. And I usually just copy and match from other things that use similar stuff and otherwise quickly grab before I run other stuff. Especially like decades ago when we didn't have Horizon and Threadripper, all these reference tools took way too long. It's not like you run this on an 800 megahertz iBook 15 years ago, or even if you had a gigahertz Athlon or stuff, it's like it grabs the stuff and yeah. Anyway, so let's, this was also the wrong press, darn. Something like the wrong focus. I mod that, hey, and it didn't crash yet. So, do we still have a temperature? We still have a temperature, that is amazing. And then the question is the decode dims. So no eeprom font. So it could be normal. Maybe this thing only looks for 80 and whatnot. So maybe we would need to patch decode dims. I mean, we would need to patch like share, like, subscribe, and all the good stuff, pattern and so on, because it takes hour after hour that I don't do other commercial stuff, right? Feeds the family. So, and it's not like the Linux Foundation has some pocket change left over for community contributions. So we would need to patch this anyway to decode it, but we might also need to patch it for probably it is only looking for IDs or classes of this module and not our brand new SPD 1514 or whatever I called it. Yeah, whatever. find name I2C, was it? Probably in this one. Yeah. Let's manual verify what we got here. Yeah, eeprom. And yeah, so the file size is there. Let's hex dump it and let's hope that is not the last thing. So again, it's a monolithic single registers microkernel, not like my vaporware dream of, did I say microkernel? Monolithic single registers monolithic kernel, not like my microkernel dream. So every small keyboard, mouse, joystick, MIDI, sound card, or freaking EEPROM driver can hold and catch fire. So if this is the last thing, but hopefully not. So this is EEPROM thing. Something happened. Amazing. Looks actually not too bad, to be honest. It actually looks like it makes some sense. For the first try, I would say. Knock on wood. Let's save that instantly. Not like my workstation crashes, fix file. This is our T2 stuff. So that, of course, needs some more cleanups, right? Not like you once live on YouTube quickly hack that and instantly send it in, right? So a little bit of cleanup, guru meditation, and so on, obviously. But for yet another, oops, we hacked some Linux kernel driver for the PS3, SG Octane, various other stuff, fixing Sun, Spark, Ultra Spark, even Fiber Channel, and implementing DDR5 SPD, hub, temperature, and eeprom support live on this channel. I hope you enjoyed this and learned something. I have to run currently 353 or whatever. Ah, right. Also pro tip, right? Obviously, when you start a new driver, you need to wire this up in the make file and a kconfig option, and then you have a nearly ready driver that can read some stuff. And yeah, of course I will commit this, like it will need some more guru meditation. Then of course I will commit this soon to one of the most, if not the most amazing Linux distribution, that is our T2, where in general lots of amazing things are improved, fixed, and just freaking working. TM. Don't forget to Patreon, GitHub sponsor. Have a good day and night, and I hope to see you soon for all the stuff we code and work on.